everyone, good afternoon. Welcome to our final lesson for Unit 2. I know it's been a pretty long one, but you guys have stuck with it. That's awesome. Thinking out loud, I think this might have been one of our longest units that we'll see throughout the year with all of the different lessons. So you guys stuck with it. You made it to the final one. Thumbs up. All right, so I cut mine out. Feel free to organize your notebook as much as however, whatever makes you happy. Let's see if I can get better at talking here. Okay, so we're going to read through each one. Feel free to try these on your own before you start the notes, and then use the notes as a check. Just do whatever works best for you. Okay, that's what this is all about. So number one. The percent y in decimal form of battery power remaining in X hours after you turn on a laptop computer is y equals negative 0.2x plus 1. Whoa. There's a lot to that, but laptops. Okay, let's think about our Chromebooks. So this word problem is about our battery power on our Chromebook. Okay, so let's think about that real-world context before we get started. So the first thing is it wants us to sketch a graph. Okay, so I need to label my X and Y axis. X is hours. Y is percent battery power. What the heck is that? Okay, percent battery power. Alrighty, so looking at our equation, rough sketch of what it's going to be, we have a y-intercept of 1. Okay, so I'm just going to put that up here because it's just a sketch. The numbers don't really matter. And my slope is negative. So if we think about it, our battery power is going to decrease over a certain amount of hours. So that's all we needed to do for part A, is just say, hey, we're going to have some battery power and the laptop's going to die. Moving on to part B. We need to interpret the X and Y intercepts. This means that I want to be able to explain what this point is and then what this point is. So, at 0 hours, Y is equal to 1. At 0 hours, Y is equal to 1, or 100%. So our Y-intercept is when the computer has 100% battery power. Alrighty, and then our X-intercept here is hours. So when the battery power is dead, it was alive for how many hours? So X is going to be the total number of hours that the computer was alive. Alrighty. Part C, after how many hours is the battery at 75%? So we're going to use our equation here. Battery power is at 75%. 75% talks about our Y. So we're going to put 75% in here as a decimal. So 75% as a decimal is equal to 0.75. So that's going to be plugged in for Y. So when the battery is at 75%, how many hours do we have we used? I'm getting myself confused because I'm looking at my notes and looking here. So how many hours is the battery power at 75%? So when 75% goes in, we're going to solve for Y. divide both sides by 0.2, and then we can say this, that x is equal to 1.25, or 1 hour, 15 minutes. So what we just found was, after 1 hour and 15 minutes of being on your computer, your laptop is at, battery is at 75%. Alrighty, a lot of interpreting on that one, so let's recap real quick. So we've got what the x and y intercepts mean, and then after an hour and 15 minutes, your laptop battery is going to be at 75%. Alrighty, moving on to word problem number 2. My cell phone's going to fall off the desk. Alright. The graph relates temperature Y in degrees Fahrenheit to temperatures X in degrees Celsius. Find the slope and the y-intercept. So part A, we're going to find the slope of 0.32 and 30.86. I'm going to use the slope formula, y2 minus y1 over x2 minus x1, on the 2 points that the graph gave us. 86 minus 32 is equal to 30 minus 0. I'm going to be left with 54 over 30, which, when I divide the numerator and the denominator by 6, I get 9 over 5. Now, when we are given the graph, we can just look at where we cross the x-axis, and in this case, it gives us that exact point. So when x is 0, y is equal to 32. So if my slope is 9 over 5, well, in addition to our slope being 9 over 5, we can use this point right here. So b is equal to 32. There's multiple ways of finding the y-intercept if you want to use something else. Now part B, we're going to write an equation of the line. So with our equation y equals mx plus b, our slope is 9 over 5, our y-intercept is 32. So our equation is going to be y equals 9 over 5x, do not forget your x, plus 32. Alrighty, last problem. What is the mean temperature of the Earth in degrees Fahrenheit? The mean of the Earth is 15 degrees Celsius. So what we're going to do is plug this into our equation, y equals 9 over 5x plus 32. Our variables here, x was degrees Celsius. So what we're going to do is plug in 15 in for x. So our x is going to be equal to 15. Okay, so we're going to plug in when x is equal to 15, because 15 degrees Celsius is what we're going to try to find for Fahrenheit. So y is equal to 9 over 15 times 15, or 9 over 5, I'm sorry, times 15 plus 32. Okay, so when we calculate that, we get y is equal to 59. So 59 degrees Fahrenheit is equal to 15 degrees Celsius. Alrighty, and that's the end of that word problem. Alrighty, now some of you might have seen this one before if I gave you a little extra practice, but if this is a new problem for you, please take a second and read through it. Okay, you're working as at a restaurant as a host and a server. You earn $9.45 for each hour you work as a host and $7.65 for each hour you work as a server. Write an equation in standard form that models your earnings and then sketch the equation. So for part A, we need a little reminder of what standard form is. So looking over at our little basic information about our John Doe here, X is going to be our number of our hours for host. So he earns $9.45 as a host. So that's going to be 945X. Plus, Y is going to be our variable for our server. So he earns $7.65 for that. And then his earnings at the end of the pay period was $160.65. So we plug that in there. And that's going to be our equation in standard form. Now part B can be complex, and it can also be a little simple depending on how detailed you want your sketch to be. And for our sketch, we need to make sure that the hours working as a host is on the x-axis, and our hours working as a server are on the y-axis. So we are going to have 2 points that are going to connect in between. Our standard form line is going to look and appear something like this. If you were to be a little bit more precise, I would solve for the x and y intercepts. So that way you get more exact points. And if you do this, x would be equal to 17 and y would be equal to 21. So this would be 21 and then this one would be 17. And if you need help with solving for the x and y intercepts, go back to Unit 2, Lesson 4, I believe. Alrighty, and we'll finish up with a quickie. I'll spare you the chance for reading, so pause it really quick. I'm going to jump right in. Okay. This graph here, you're writing from school to home. It relates your distance, y, to your time, which is x. So A, how far away from home are you when you leave school? We're going to look at our graph. The maximum distance away is 12, so we're going to say we are 12 blocks away from home. Part B, how long will it take you to get home? Well, you're here when you're at, your distance from home is 12. When your distance from home is 0, that means you're home, right? So that's going to be 10, 0, so 10 minutes. And then part C is writing an equation of a line. So we need to find the slope and the y-intercept. Okay, actually the y-intercept has already been given to us, so we only need to find the slope. So we have points 0, 12, and 10, 0. Y2 minus y1 over x2 minus x1. So I'm going to have 0 minus 12 over 10 minus 0. So I'm going to be left with negative 12 over a positive 10. I'm going to divide my numerator and my denominator by 2. So I have a slope of negative 6 over 5. So that's going to be my slope. And my y-intercept, again, since I'm given the graph, I can just look and see when x is 0, whatever y is equal to is my y-intercept. So b is going to be equal to 12. So I'm going to wrap it up with my equation, which is y equals negative 6 over 5x plus 12. And that's it. See you tomorrow.